but if you don't know the derivative rule, like it's good that you said that there. Sometimes though you want to take an action though. You want to like say, well, if this was the derivative, here's how I would do the rest of the problem.
Yeah.
And that's where it was lacking. So
Also, the test was before we did the first set of tutoring as well, so
okay.
I was not like completely confident on even like basic derivatives.
Yeah, so this one is nearly impossible without knowing the
Inverse.
yeah. I mean, you can't even. I mean, you can maybe derive it with some triangles and stuff if you're really creative, but
Yeah.
that's not what's there. So this x right here is whatever this x is. In so whatever you're taking the cotangent inverse of, that's what goes in that x there. So dy dx or y prime is 2 times negative 1 over 1 plus, and then in parentheses here, it's this x squared plus 4.
Mhm.
Okay, all times chain rule, derivative of this inside function is 2x.
Okay.
Do you know if your instructor wants you to simplify or?
I think she probably does, at
Okay,
least for problems like this.
okay, so we can see like 2x negative, so negative 4x over, and then you don't actually need to expand what's inside here. Sometimes there's some rules that seem to go against what you may have already learned.
Yeah. Okay.
That. Okay. Do you have a derivative sheet? And if I've asked you before, my apologies.
Yeah, I have one right.
Okay.
Right.
All right. Okay. B. Y equals 7 to the 3x. Okay, so the overarching derivative rule is the a to the x rule. Let me snip that in here. I think that could be useful for you. So again, when you have the rule, it's pretty straightforward here. The derivative dy dx is itself. It's like e. E is always itself. This one though, you have to take the natural log of the base, which is 7, and then you have a chain rule part to go along with it.
Okay. Sometimes.
Yeah, so this is pretty much, I mean, you might go like 3 natural log of 7 times 7 to the 3x as your final, pretty answer, but it's all the same there.
Okay.
Oh, and let me know if you want me to give you ones like this as we go.
Okay.
How do you think you would have done after our first lesson if you'd had this quiz?
Probably a lot better.
Okay. Yeah, I think so too. There's
Yeah.
not much here that's
Yeah.
weird or anything. So this is a product rule. And I would put the 5 with the x rather than like leave it off to the side. And here are your two things. Is this the one that you use, or is it something else? So that I can for the product rule, uv prime plus vu prime. Is that what you use, or do you use something else for? I'm gonna go with that then. Let me know if you are still. Ella, you are still here. Is that right? Maybe you're muted. I'm gonna chat you real quick.
Sorry, my Wi-Fi completely just cut me
No
out.
problem. Do you use the UV prime or the VU and the VU prime here for your product rule, or do you use something else? Do you use F and G?
No, I use that.
Okay, so we're gonna keep the first 5x, and we're gonna take the derivative of the second. So derivative of ln is always 1 over whatever's inside parentheses. So 3x squared times the derivative of the inside function, which is 6x. So there's a lot that's going to simplify here. Plus, keep the second times the derivative of the first, u, which is just 5. Okay, so on the left here, this ends up being 30x squared over 3x squared, which ends up being 10. And then this is just on the right, it's just 5 natural log 3x squared.
Okay.
I'm not sure if you heard me when I said, if you want ones like this, let me know, and I could certainly give you one just like this,
Yeah.
a related one. Okay, moving on to D, another inverse. I just to be full disclosure, like I have to look these up because I don't really need this information anymore, but like you just have to learn it for the class.
Yeah.
This is a quotient rule, and it's a quotient rule with an arc sign. So you got to really, know this. It's bottom, derivative of the top, minus top, derivative of the bottom, over the bottom, squared. So dy dx, and then log base 2 is kind of like ln. It's just a little variation on it. Not used very often, but that's what they have here. So you have log base 2 of x cubed, okay, times. Now I gotta go back to that reference sheet, and I'll snip in what arc sine is.
Okay.
You'll find that, like, if you haven't memorized these yet, like arc sine and arc cosine are very much related. Arc tangent, arc cotangent are very much related.
Yeah.
So this is, again, the x is whatever you're taking, whatever x is here. So this is the derivative of this is 2 times 1 over square root 1 minus x cubed squared. Then you got to take the derivative of the inside function, which is 3x squared. And now we're up to this minus. So all of that was u prime.
Okay. Wow.
Yeah, it's horrible. Okay, and then we got to take, we got to just rewrite the top, 2 arc sine inverse of x cubed, and then now we got to take the derivative of the bottom. So log base 2, it's kind of like ln, it's 1 over whatever's inside, natural log of the base is 2,
Okay.
but then there's chain rules, so it's the derivative of the inside function, 3x squared. Thankfully, a lot of this cancels.
Yeah.
But it doesn't help here when you're writing all this out. Teacher doesn't give you much room on your side, so just do the best you can on this. So then you square the bottom. Okay, so on the left here, like on this all of this is mashed together. Not maybe just rewriting it, it's going to show you it's 2 times 3x squared gives you the 6x squared log base 2 of x cubed over square root 1 minus x to the 6th. So that's all of this first part minus.
Yeah.
Okay, this x squared and this x cubed are going to cancel. So you get 2 sine inverse. Oh, I'm sorry. The 2 times the 3 is going to make 6. So do that. And then there's an x. Okay, that's on the bottom. X cubed over x natural log of 2.
Okay.
All over. Okay. Log base 2 of x cubed squared. There's really nothing to do on the bottom. Now you can further simplify this. My guess is the instructor did not. You would have to find a common denominator between the root of x1 minus x to the 6 and x natural log of 2.
Yeah.
And that it just creates a lot more stuff. And then you have to bring this up a textbook would simplify this, but like if you're using a WebAssign or something for online homework, it would accept this as is.
Okay.
Would you like me to go further on this?
No, I think she would accept it. How it
Yeah,
is.
okay.
She just
Okay, we're
wants to see that we know how to do it, not that we know how to like simplify.
yes. Yeah. All right, letter E.
Yeah.
Letter E here. All right, so this is a I call this a function to a function. And you're and sort of like before this, you know, like x to a number or a number to x. Now it's got like x in both places. It's like x to the x basically, or f of x to the f of x. And the only way to do this is to use ln, logarithmic differentiation.
Okay.
And this is like a specific thing. You have to have seen it to know how to do it, and then you have to recognize it when you see it. So you take the natural log of both sides first.
Okay.
Which again, like you wouldn't know unless someone told you, because why would you know this? This is
Yeah.
completely unreasonable.
Like all of calc.
Yeah. And then you're allowed to bring the exponent out in front. So this is the natural log x to the n equals n natural log of x. This is 6x minus 8 comes out in front. So you have natural log of y equals 6x minus 8 in parentheses, because that all is multiplying natural log of cosine x.
Okay.
So there's been no calculus to this point, okay? But all of these problems, and like the bonus is just like this, where you do the ln of both sides, and you get this. So now on the left, you do what's called implicit differentiation. Have you seen or heard of that?
I've heard of it. Yeah.
Okay, so assume this is an x here. You would write 1 over y, because it's really y, but then the derivative of y is always y prime. That's the chain rule part.
Yeah.
Okay, now on the right, it's almost always product rule. A few occasions where it's not. This one's product rule.
Okay.
Okay, so that's the uv prime plus vu prime. Good to write that out if you know as you're learning it. So 6x minus 8 times derivative of the right here. So it's 1 over cosine x. Derivative of the inside function is minus sine x, plus keep the second function, natural log cosine x, times the derivative of the one on the left there, which is 6.
Okay.
Now on the left here, this is written as y prime over y. So if you do a bunch of these, you will eventually just immediately write y prime over y. But for now, you can see how it becomes that.
Okay.
Sine over cosine is tangent. That negative can come out in front. You can even distribute the negative to both. So it becomes 8 minus 6x times the tangent of x plus 6 natural log cosine x. Okay, now we're not done, because we have to solve for y prime. Like if you looked at every single problem I did, it was always, you know, y prime or dy dx, y prime dy dx. Okay, so to solve for y prime, you have to multiply both sides by y. And I'll just show it here once, because it's worth seeing. But they're all like this. You always end up multiplying both sides by y. So the y's cancel. Okay, but you do not leave your answer in terms of y. You have to go back and be like, well, what was y? Well, y was your original function. Your original function was cosine x to the 6x minus 8 power.
Okay.
And so all of this is that y there. And these always look real messy like this. They're not clean at all.
Yeah. Okay.
Move on to F now.
Yes.
Okay. Okay, so again, like you got to have the cosecant inverse formula down.
Yeah.
It's like not one that you could ever use, but
Yeah, I gotta memorize.
yeah.
There's a little more. I have
like
like a basic idea of them, but not like fully.
Yeah, it's like a trick play in sports. You just don't use them very often. So
But you still have to remember
you
them.
still have to know them in case they're called. But but limiting returns. So again, this x right here and this x right here, they come from whatever is whatever you're taking the cosecant inverse of.
Yeah.
So dy dx, or y prime, is -1 over the absolute value of 4x cubed square root of 4x cubed squared minus 1.
Yeah.
And then you have chain rule. So you have to take the root of the inside function, which is 12x squared. It's not okay to cancel out like x cubes and x squareds up here because it's an absolute value.
Yeah.
So you just have to leave it. Minus 12x squared over absolute value 4x cubed. Square root, this one I guess we can reduce. It's 16x to the 6th minus 1. And you're done.
Okay.
Would you like us to do the bonus?
Mm-hmm.
Okay.
We can do it.
Right. Not difficult, a lot of writing. You'll see why after we do this. So again, this is kind of like E. You have to know, and the instructor kind of tells you, I think it says to use logarithmic differentiation. You have to know to take ln of both sides. So it's natural log of y equals natural log. And I'm gonna like kind of cheat here and just snip this in again. Natural log of all that. Okay. Now there's all these logarithm properties. Were you good with your logarithmic properties?
Yeah, pretty good.
Okay. So it's the a plus the natural log of b. You got the subtraction one. A over b, natural log of a minus natural log of b. And then the last one is natural log x to the n equals n natural log of x. So you're just expanding the this thing right here. So it becomes 1/3 natural log of x squared minus 5x plus 2 minus natural log of 2x cubed plus 1 minus 1/2 natural log of x to the 7th plus 5. So that's incorporating all three of those properties into that. No calculus yet. But the nice thing about the derivative of ln is it's always 1 over.
Mm-hmm.
Okay. So this line is clear, or this is okay?
Yeah.
Okay, so on the left, it becomes y prime over y. It's 1 over y times y prime, or the derivative of that. So then, okay, we got to take the derivative of these. It's 1 over, the 3 comes from that 3, x squared minus 5x plus 2 times the derivative of the inside function. So at some point, you got to just start writing it in the numerator and not like, that way you can save yourself some time writing it. So 2x minus 5 is the derivative of this in the numerator.
Okay.
So what I used to do is I used to just write it like this: 2x cubed plus 1, and then not even put anything in the numerator, and then wait for the chain rule to go in there.
Okay.
And then down here on the bottom, that 2 goes here, x to the 7th plus 5, and then the derivative of the inside function is 7x to the 6th. Okay, but we're not done because we have not solved for y prime. So y prime is everything you just wrote. This is where you almost want to get out your pencil, your eraser, and just erase the y on that previous line, because you're going to multiply all of this by y, and y is this, this horrible mess here and from the beginning, and that's where you're going to put that, because that is your y, all of that.
Yeah.
So notice, like, it's just like that problem we did up here in E where you end up multiplying by y again. They're always like that. They're never.
Function.
Yes.
Okay. Okay. That makes sense. I just need to get my derivatives of inverse functions down.
Yes, definitely.
Let me see if I can pull up my homework. Gotta pull up the textbook. Okay. So this unit's confusing. I don't know what it really all means, but it's okay.
It'll all make sense by the end of the class, if not sooner, and then get to your AP. And this is an AP class, right? AB calculus.
Yeah. Okay. So look at what problem she assigned.
So just chatted you the email or text to send over pictures or whatever you want to work on.
We won't get through all of this. I'll just send two pictures. Reply to the booking confirmed email. Okay, they're loading. Correct. I'm gonna say what numbers were assigned. There. So I sent pictures of the textbook, and then at the bottom there's pictures of, not pictures, there's the numbers that were assigned.
Okay, I'm looking now. There it is. 19 through 24. Oh, great, optimization problems. These are quite difficult.
Yeah.
They rely on you to be able to write the function, then take the derivative, set it equal to 0, and so on. Which ones? Just try to do all of them, or what's the?
No, 19 through 24.
Yeah, this would just start with 19.
Yeah.
Okay. So I'm just going to throw this in the chat, so I don't have to keep going back and forth. So 19. Right. Oh, the ladder problem. All right. So classic exam problem. Slip this in. Okay. So they're giving you the shape. Sometimes you took geometry at some point. I'm sure they don't always give you the shape. Sometimes you got to draw it. So a 13-foot ladder is leaning against a house when its base starts to slide away. By the time the base is 12 feet from the house, the base is moving at a rate of 5 feet per second. Okay, so there's a triangle here. I'm just going to draw it again. And there's two sets of numbers you need. So there's the non-calculus numbers, like if it's a 13-foot triangle and it's 12 feet from the house, the other side is 5.
Yeah.
And then it's good if you can do it inside the same triangle, but there's also, so this is like X, Y, and we'll call this D. And then there's also X prime, Y prime, and D prime, which are your calculus numbers.
Yeah.
Like for example, and you get that from like when it says feet per second, because it tells you a rate, that's always a derivative. X prime is 5, okay? And we're trying to find Y prime. That's what A is asking for.
Okay.
And we'll get to how to do this, but like this has to be clear. D prime equals 0 because the ladder itself is not changing its size.
Yeah.
Like as it falls, this distance is increasing and this vertical distance is decreasing, but the ladder itself does not change. But that's not to say that there's not a problem where this could change.
Yeah.
So you have to know the governing or overarching, like how do you describe the equation of a triangle? And that's the Pythagorean theorem.
Yeah.
So you have to know this. You're like, oh, okay, x squared plus y squared equals d squared. Some instructors use z, a, b, c. Like it doesn't really matter as long as you like whatever letters you use, you understand what they mean in the context of this problem.
Mm-hmm.
So in terms of how to take a derivative, like you already know this. You know, okay, it's 2x, but it's now x prime because everything is defined implicitly.
Yeah.
So that makes it plus 2y y prime equals 2d d prime. Okay, now there is no d prime. We're going to board 0, but you don't want to jump to that conclusion yet.
Okay.
Okay, so from here you solve for the quantity of interest. So like we want y prime, so you got to solve for y prime here. So y prime equals 2d d prime minus 2 Too many D's there. Move that over. 2x x prime over 2y. And then you can cancel out the 2's if you want. So sometimes on an exam, like they ask you for the equation and then to actually get the value. So you just substitute what you know.
So like 0 for D prime.
Yeah, so you can throw all the numbers in. 13 times 0 minus what is x? X was 12. X prime was 5 over y. Oh, we do know y. Y is
5.
5, yeah. So this ends up being negative 12. And the units are feet per second. Now, does this make sense in the context of the problem? So like it's negative because it's sliding down.
So
That
it's
makes sense.
decreasing.
I'm sorry. Yeah.
It's decreasing, yeah.
If you had gotten positive, that would be incorrect. But sometimes they don't tell you which way it's moving, so you have to just go with whatever sign it is that, and hopefully you did it, did all the signs right in the context of the problem. All right, so let's go
B.
B. So A is really like a complete question. B is like the same question, but it's asking something completely different. So you have to like almost restart. You're going to reuse a lot of the same quantities.
Yeah.
So a rep rate is the area of the triangle formed by the ladder while on ground changing at that moment. So the area of a triangle is 1/2 base times height. The base is X and the height is Y. Okay, so now the derivative of this, because that's what it's asking for, it's the rate, the area of the triangle, okay, is so this is a product rule. So it's like a UV thing here.
Yeah.
So it's the derivative is 1/2 X Y prime, that's derivative of V or Y, plus Y. Derivative of this is 1/2 X prime. 1/2 from the X and then the X prime always. So so this becomes 1/2 XY prime plus 1/2 X prime Y. So do we know any of these values? Well, we know that X is 5. Now, what is Y prime? Now we assume because it says at that moment, like it's referring to the last part of the problem, but they could just as well change it. So we found Y prime to be minus 12.
Mhm.
Okay. And you might think at first, well, that's not good because area can't be negative, but we're talking about the rate of change of area. So like, is the triangle getting smaller? You'll see like, yeah, it is, because it's going to be down here. It's going to be getting smaller. I think.
Is it X 12?
Yes, it sure is.
Okay. I was like, wait.
Yeah, please, always, you can jump in and correct me anytime, because I'm not gonna
X
object to that.
prime is 5.
X prime is 5, and then Y is probably 5.
Yeah.
Okay. So this gives you minus 144 1/2 minus 72 plus 25 over 2. So that's 12.5. So it's negative 59.5. The area of a triangle is feet squared,
Yeah.
but then you have to give it a unit of time, feet squared per second.
Yeah. Per second.
So it's always the whatever unit it is divided by some unit of time.
Okay. He's asking for the rate, not just the.
It's actually only for the rate. Yeah.
Yeah. Okay.
All right. At what rate is the angle between the ladder? I have to draw a picture again here. Between the ladder and the ground changing at that moment. So again, your picture, something like this. This is the angle right here.
Yeah.
So I guess you want to use tangent. So like tangent of theta equals y over x.
Mhm.
because I mean, you could use sine, cosine, you could really use any of them, but I think they generally want you to use tangent when you do these problems. You might check with your instructor and ask, like, do you care which ones I use?
Yeah.
You just end up getting different quantities. Cosine is x over d, and you got some d prime. So I think it's actually simpler, but anyway. So the derivative of the left side is secant squared theta times theta prime. That's derivative tangent secant squared.
Okay.
Okay. And then it's bottom times derivative of the top minus top times derivative of the bottom over the bottom squared.
Yeah. Okay.
Okay, so now we're trying to find the theta prime, which
Mhm.
means that you need to so secant, and this is where, I mean, okay, secant squared is really 1 over cosine squared theta. So it's like multiplying both sides by cosine squared.
Uh-huh.
So there's now a cosine squared in the numerator. So we've got some of these values. X is 12, y prime is -12. Minus y is 5, x prime is 5, I think.
Yeah.
Means, and then x is 12.
Yeah.
12. Okay, now what is cosine of theta? So we got to go back to the original. Cosine of theta is x over d. X is 12 and d is 13. So this thing on the right here is actually just 12 over 13
Okay.
squared. And then that simplifies to whatever it simplifies to. A lot there.
Yeah. Okay.
We should definitely do 22.
Okay.
It's a classic problem. I mean, 20 is good to do as well, but I know 22 is one that occurs a lot. Let me see what else is being asked. Oh, is it just that? Oh, it's just that. I was looking for there's this sort of, a sphere increases or a puddle increases at a rate of, but I don't see that here. So where do you want to go next? Actually, so 22 is not that problem.
Well, I'm not sure.
Let me look
I'm
at,
fine with whichever.
okay, let me just really quickly get to the chat again. There it is. 29 and 24. 9, 32. Yeah, I mean, let's just go. We'll just do them in order. I mean, there's no gains here.
Yeah.
Okay, a trough is 15 feet long and 4 feet across the top, as shown in the figure. Its ends are isosceles triangles with height 3. Looks like it's got a base there of 4. Water runs into the trough at a rate of 2.5 feet cubed per minute. So that's a little bit new, but that's your V prime right there. It's giving you the derivative of it. And it says, how fast is the water level rising? We'll call that H prime when H is 2 feet deep.
Yeah.
Okay. So the we have to find the area of this thing here. So the area is 1/2. It's in the right place. The area is 1/2 base times height. So that's like, this is B and this is H here. Okay, times the length.
Mhm.
The length is unchanging, which is nice because otherwise would make it real tough. But the base and the height, they are changing.
Mhm.
Okay, and one of the things that's not good here is we like, if we were to take a derivative of this, like assume that L is a constant, you would end up getting a product rule of B and H, and that means you need to know B prime and H prime. H prime is fine because you're trying to find it. Let me actually just do that here. So let's say it was 1/2 L. Okay, and your prime would be BH prime plus HB prime. And you don't know B prime. It's not given. You can't find it. So that's no good.
Yeah.
Okay, so you might say, well, how do we do this? Well, in a lot of these problems, you have to build what's called a similar triangle. So
Yeah.
if this is H and this is B, maybe you saw this in class, you just write a ratio like H over B equals, well, what's the max height? The max height is 4, and the max base is, I don't know. I'm sorry. The max height is 3, and the base is 4. And then you can solve for one of the variables. So you solve for B because you don't know B, and you don't know B prime, or you don't know B prime. So if you solve for B and you get B equals 4/3 H, what that does is when you put this back into your A, you only have an equation in terms of like one variable, which is very nice.
Yeah.
So if this is not clear, let me know so we can go through it again, because it's very, very important.
Mhm.
So the area is 1/2 4/3 H times L.
Okay.
And actually we know L is always 15. So we actually can substitute in 15 for that. L equals 15 always. Okay, so we should simplify here a little bit. So that's what, 2/3 15 divided by 3 is 10. So it looks like it's 10H squared. I'm sorry, and this is volume. This is not area.
Okay.
Volume. And then we change it up here. Okay, so the volume is now in terms of H. That's way better. V prime equals 20H H prime. And we want H prime. So H prime is equal to V prime over 20H. V prime is 2.5 and H is 2. That's given when the water level is exactly 2 feet deep.
Okay.
This one actually worked out nicely. So it's 2.5 over 40, 1.5. So it's like, yeah, whatever it is. But the key really is knowing this similar triangle thing. If you did the growing sand pile problem in 16, it's kind of like that.
Yeah.
The height and the radius end up being related.
Mhm. Would my units for this one be just the same as the other ones, feet cubed per minute?
It's a height, so height is in feet. You just think about whatever the unit is. If it was V prime is in feet cubed, but then it's per unit of time. Actually, this one's per minute, it says.
Yeah. So it's just feet per minute.
Feet per minute. Nope. Because so lengths are length per time. Areas are whatever its length, lengths squared
per time
per
and
time. Yeah.
length cubed per time. Okay.
All right, so we can, I guess we go to 21.
Yeah.
Okay. A dinghy, calling in a dinghy. Okay. Sometimes it's a boat. I mean, it is a boat, but a dinghy is pulled toward a dock by rope from here. So this is the rope. Sometimes that's unclear if you haven't been out in the water.
Mhm.
Through a ring on the dock, 6 feet above. So that's 6 feet above the bow. The rope is hauled in at a rate of 2 feet per second. So like this is D, or R, or whatever, whatever you want to call the like hypotenuse of the triangle. This is D, and D prime is 2. Okay. Now in part A, they're telling you that it's 10 feet of rope. So they're telling you D equals 10. Okay, and they want to know how fast is the boat approaching the dock when 10 feet of rope is out.
Yeah.
So they want like X prime here. Now Y and X here, Y prime is 0 because the height is not changing.
Yeah.
Okay. So that keep that in mind. This is another triangle problem. So it's the x squared plus y squared equals d squared. But this time, like d prime actually does exist because that's changing, but y prime does not, as we just mentioned. So it's the 2x x prime plus 2y y prime equals 2d d prime.
Yeah.
So now all the twos cancel, and we're solving for x prime. So x prime equals d prime minus y prime over x.
Yeah.
And so let's see if we have some of these numbers. We do. D is 10, D prime is 2. Now we're sort of artificially choosing that it's going like that way is positive, but that's okay. Minus, well, we can find Y, but well, Y is 6, but Y prime is 0. Now we don't have X. So to get X, we have to make the triangle again. This is 10, this is 6. So it ends up that X is 8. So a lot of Pythagorean triples. So 3, 4, 5, 5, 12, 13, and then any multiples thereof, 8, 15, 17. Your instructor probably will give you this. So this is a good kind of a thing to do. So that's over 8. So it's 20 over 8, which is whatever, 10 over 4, 5 over 2. 2.5, and then it's a length this time, so that's feet per second.
Okay. Yeah, that makes sense.
Okay, now part B, if you've got it in front of you, it says at what rate is the angle theta changing, and that's the one up here. So if we use tangent, it's x over y. We can definitely do that because we have all those variables. Get probably one of those things to check with your instructor, see if they have any guidance on that. I mean,
Yeah.
Because you couldn't literally choose anything. You use cosine, whatever. We'll just do tangent again. So tangent of theta this time equals x over y. So now we got to take a derivative. Secant squared theta times theta prime equals y x prime minus x y prime over y squared. Okay, and then secant squared is really 1 over cosine squared. So you can move it to the numerator, y x prime minus x y prime over y squared times cosine squared theta. We just got to get the numbers in again. So y is 6, x prime is 2, x is 8, y prime is 0 over y 6 squared. So cosine theta so here's theta. It's 6 over 10, so it's 3/5 squared, like that. And this one, so this ends up being on the left 36, I'm sorry, 12 over 36. So one of the sixes cancels, you get a third. You get a third times 9 over 25. So you end up getting like 3 over 25. And then it's an angle. Angles are in radians per second. That might be the most important part of this problem, is angles are always in radians per second. I don't think we filled that in the other one.
Yeah.
Well, thanks so much for scheduling, and appreciate you doing it. If you ever need a lesson time that's not listed, just text me and I'll add it for you if I can do it. I'll send you the notes actually right away, and you'll get a link to the screen recording in that email, but you just go to the YouTube channel to find it.
Okay.
Hope
Perfect.
you enjoy the rest of your day and got some good stuff out of it today.
Thank you so much. Have a good one.
You're welcome. Bye now.